In this video, we are going to look at techniques for checking and correcting numeric data using Excel. Now, you may want to use this in the JunoViewer framework with several tools. For example, with the JunoViewer ICC template, with a Juno-Cassandra check and add template, or within your deterioration model setup or DMS file. This checking and correcting of numeric data is something that I found can get quite complex unexpectedly, and it often the complexity may often catch our users by surprise. So I thought to just make a video specifically about this feature. Now let's look at the principles of the ICC template and the JCass template for adding and checking data. The principle is the same as with the DMS deterioration model setup file. Essentially, your raw data is going to come from a file or from the database, and what the ICC template or the JCass template then does, it takes the data, and JunoViewer will take the data and step through row by row and place the values from that row into inputs or placeholders in your ICC or JCass template. You then do certain calculation checks to make sure that your data is correct, or do other calculations, and those outputs then are going to go into a finalized data set. So JunoViewer is using this Excel file as a calculation template, and the data from there is going to go back into the output file or back into your database, depending if you're using JCass or JunoViewer. And that process is then repeated row by row and until all your data is completed. So we're focusing on this video on this calculation checks component, specifically to check that there's no errors in the numerical data that you expect from this input data. Now let's look at an overview of our approach. Remember, in this video we're dealing with numerical data. So we get our raw data value, and we expect there could be anything in that raw data. It could be an invalid number or a number that's outside of our expected range, and we want to handle all of those cases. So the first thing we do is we check whether the data represents one of our missing or unknown placeholder values. If that's the case, then we set the value to whatever is our, let's call it our authorized or our official value to represent no data, or we can use a default value. And I will explain that later in detail when we actually look at this in Excel. So if the value is not in the list of known, missing, or unknown labels, then we're going to do the next check, which is this a valid number or not? So if since we are expecting a number, if it's not a valid number, then we are going to set the value to error, or we could also set it to a default value so that our downstream processes can elegantly handle that. What we don't want is for some invalid text value to go into a deterioration model or into a quantity calculation algorithm or something like that, where it's going to cause problems. If it is a valid number, then what we want to do is the final cleanup, which is to clamp the value to ensure that it is within the acceptable minimum and maximum range, so that values that are too high or too low will not enter into the further downstream processes. So after we've done the clamping, then that will give us our final value. So we're going to have these three possible values that will be passed forward into our validated value, which is then ready to go into whatever downstream processes we have. So as you can see, it's not that straightforward to just check numerical values. So I'm going to now go in Excel and show you how we do these checks and these calculations. Before I go over to Excel and exit this presentation, I just want to talk briefly about this process of clamping a value within acceptable range, because when we're doing this in Excel, it can look a bit complex, and I just want to simplify that up front before we go to Excel. So this is basically what we want to do. We have got a minimum allowed and a maximum allowed. So let's say, for example, it's a percent value, and we want to make sure it goes between 0 and 100 and never outside that range. Now the value that we are going to get is going to sit somewhere here. It could sit over there, in which case it has to be brought back to the maximum, or it could sit over here, in which case it has to be brought back to the minimum. And this is what our clamping process will do. So the first step, normally we would have already done that, is to check whether that's a valid number. We check the raw value, and this then is our validated value. So the next step then is to make sure that we keep it within the maximum limit. And here we're going to use the Excel formula min, and we're going to take the maximum allowed, which is this one here, and the value. So we're going to take the minimum of these two. And that's why I want to explain this first, because since you're checking for the maximum, it sometimes seems counterintuitive that you're using the minimum. But if you think about it carefully, if this value was sitting over here, we would want the minimum of this value over here and this maximum allowed, which will in that case be maximum allowed. The opposite applies to check the minimum allowed. So there, to keep it within the minimum limit, we're going to take the maximum of this value over here and this value, right? So if this value was sitting over here too low, it will bring it up to the minimum allowed. And what we're then going to do in Excel, and this is a little bit tricky, is we're going to replace this value with this entire value to just chain this equation together. And the final clamp value will then look like this. It will be the maximum of the minimum allowed, and then in the position of this one, we're just going to put this formula like that. Okay, so when we get to this point in Excel, if you get confused, just go back in the video, look at this explanation again, and it will explain it for you. Okay, let's go over to Excel now. And what I've got here is the Juno-Cassandra template. It's a little bit different from the ICC template, but the principle is the same. So over here, we have our input columns, right? So we've got our column names and the values, and our JunoViewer is going to pick up these column names, and it's going to look for these column names in your raw data, and it will put the values in here. So I'm just going to replace that value with 1, 2, 3, for example. And then in Juno-Cassandra, it will take these column values and their associated output values, and these will then be the outputs. So if there's no change, if my formula is basically just like this, then this process would have no effect, because JunoViewer is going to place the values in your database in here, and it will take those same values out again to your output process or your output file. So that will have no effect. But what we want to do is to do this a bit more intelligent, so that we do those checks that we noted earlier. Now, if I wanted to, I could build a very complex formula in here to do all of the checks that I want to do. But that is not an approach that I generally recommend. So what I've done over here, I have just broken down that flowchart that I showed you earlier into different steps. And I'm going to show you some tricks and caution you about some things that could go wrong. So the first thing I want to do, remember in this row over here is where my raw data value is going to come in. If you are working in the ICC template or in a DMS file, these column headers will look different, but the principles that I'm going to demonstrate to you here are the same. Okay, so the first thing I'm going to do is I'm going to take this value over here and I'm going to convert it to a lowercase value and a trimmed value so that any blank spaces are replaced. So I'm going to say equal lowercase, right? And I'm going to say of the trimmed value that is in here. Okay, now notice this value now is no longer a number, it's now a text value, right? So if I, for example, enter a number 1, 2, 3 in here, and I say equals if this equals this value over here, then put match otherwise put no match. You will see it says no match because this is a number. I've just entered 1, 2, 3 in here, and this through this formula over here has been converted to text. So that's an important thing to take into account. Right, now we are going to look at this list of our known possible values that represent no data. So for example, I could have in a cell something that says no data, or NA, or null, or I could have -999. Now what we want to do is we want to say, is this value over here in this list? Because if it is, then I know that this value, this raw value over here, is representing a no data value. So to do that, I'm going to use the match formula, right? So in Excel, I'm going to say match, and you can see here Excel says it returns the relative position of an item in an array that matches the specified value. So, and it asks me, what's my lookup value? This is my lookup value, and my lookup array is over here, right? And the match type should be an exact match. Okay, now you see this is giving me a not applicable because this is not in the list, and that's exactly what I want to do, because now I can use this to tell me is this no data or not, right? So I can now say equal if is in A, right? If this is not in A, then this is not no data. If it is something other than in A, then I know it is no data. Okay, let's explain that a little bit. Let's put a value in here that's in this list. For example, no data. I'm going to use a different case, right? And you can see that's why I used lowercase and also trim, because let's say I had some spaces at the end here, it wouldn't matter because this is going to be the trimmed value. And you can see this match formula, because this is not in A, my formula here says if it is in A, then it's false. In other words, it is not no data. But if it is something other than non-A, in other words, like this one index here, then it is no data. So now I know, if I go back here to my flowchart, I'm looking here at the first element. Does the raw value represent missing or unknown data? And I can see in this case, the answer is true. Yes, it does, because this value is in this list. Let's test the others. I got NA in there. It says it's index 2, so it is no data. And I've got null. Maybe some process will put the text value null in there. Again, it's true. Right? Now we're going to come to a tricky one. -999. Right? You see it's false. But this value is in my no data list. Why is it not matching it? Well, that's what I showed you earlier. This formula over here is converting this to text. So all I must do to correct that, if my no data values contains a number, I must just put an apostrophe in front of it to convert it to a text value. And now it's going to pick up that it is true. So now I've checked that all of my possible no data values will flag this. If I've got anything else, for example, 1, 2, 3, this no data is false. So I know it's not a no data case. Right. The next thing to look at is what will happen if there is something that is not a number in here. So for example, hello world, right? This is a hello world. It's not a no data, right? Because it's not in this list, right? So in my flow chart, I'm going to go on here and I'm going to ask, is it a valid number? Now all I'm going to do here is I'm going to use this formula that says equal is number, right? And again, I shouldn't check this value over here because this is a text value. We know that's a text value regardless of what's in there. So I want to go directly to my raw data, right? And it says it's false. So since it's false, it's going to go in here, and it will set the value to error. We'll get to that. We'll get to that a bit later on. Right. So let's see what happens if I put in minus 999 in here. Okay, it is a valid number, but it's also in the no data list. So I'm going to exit my process before I get here. In this process, I'm going to exit on this ramp here instead of going here. Okay, so now I've done the first two checks. Now I want to go to this check, and here I want to put in that formula that I had earlier. So let's say, for example, here I'm working with something that's a part ID, and I know a part ID can only go between 0 and 1000. Right. So my clamp value is then, again, don't use this value, go right back to this value. I'm going to say equal the minimum of my allowed maximum and the part ID, right? So that will clamp it to the maximum, and then to check for the lower bound, I'm going to enter in here. I'm just going to go into this formula and say max of the minimum value, comma, and the previously clamped value. Okay, so see, since I've got a minus 999, it's clamping it to a 0. If I put in a 123.45 in here, it will put in there a 123.45. If I put a value bigger than 1000, let's say 2345, it's clamping it to 1000. Okay, so now I've got everything in place to calculate this final value that's going to come in here. All I need to do is to pick which one of these three I'm going to be using. Okay, and so now I'm just going to use the if statement, and this is going to be my default value. Let's say I want to have a default value of 55 in this case, or let's say part number 1 is the default. And if there's an error, I want to put the error label called unknown, or no, let's say error. Right. So now I'm simply going to go through this list here and pick the appropriate one. Okay. So I'm going to say equal if no data is true, then use the default value, because I don't have data in that cell, so use the appropriate default, right? If that's not the case, then I want to say if it is a valid number, then use the clamp value, otherwise put the error label. And I need to put 2 brackets around this to close it, and that's what I get, right? So my clamp value is 1000, and the final value here, which I'll just highlight in bold and maybe make it another color like that is going to be my final value. And now I can test it thoroughly. I can go and put in here some strange value, hello there, right? And it tells me this is an error, right? It's an error because I'm expecting a number, and this text value is not in this list, right? So if I decide, well, if there is an error, then actually just put the default value, well, then I can just make this equal to that, right? And then it's going to put the default value in there, right? So it really depends what your downstream process looks like, how you want to handle it. So what I choose to do normally in this case, I would put unknown in both of these cells, and then I handle this uniformly downstream. Right, so for example, in Juno-Cassandra, which is our new beta version modeling framework, we've got downstream of this checking process, we've got a sophisticated imputation algorithm which will be able to handle all unknown values by looking up with a sophisticated lookup what is the most appropriate value based on what the rest of your network or your asset system has available. Okay, but for this case here, you may want to use something that just says, well, use a default value, let's say 22, and if it is an error, then put error. And then you can handle that downstream. Right, so you can now handle any case. So minus 999, in this case, it's going to put this default. It's not, even though it is a valid number, it has picked up that it's no data and it's putting the default, right? If I put in here not applicable with a space behind it, it's also handled, and the final value is once again the default, right? Because it's one of the no data values, right? So these are the formulas that I've laid out for you, and if you go back in the video and you look at this formula bar here, you will see in detail how I use this. Now, of course, once you've done this for one numerics column, you can just repeat this process for all the others. And the place I normally prefer to start is by filling in these values properly. So for example, in this column represents maintenance cost. And the default for maintenance cost generally would be 0 because maintenance occurs not so often, so that would be a 0. I would again have this error label here. And my minimum would be 0. And let's say, for example, it would be very unusual to have something outside of $30,000 maintenance cost. Then you could put that maximum there. Number of incidents, again, default would be 0. I'm going to put just here something else, so unknown. And minimum is 0 and maximum, let's say 100 incidents would be the maximum you would expect. And I've got another column here called book value, and I'll just put the same, maybe say a book value of 1, 2, 3, 4 as a default. Error if there is not numeric data in there, and the book value can go from 0 to let's say 10 million. Right, so that would clamp it. So first of all, I fill these in. Now that I've done that, I can just go and copy these. Oops, there's just one additional thing I need to do is to fix this range over here so that I can drag those cells down. All of the rest here is not necessary because these cells are not looking up on anything. Here I have used just the direct range. Normally I would use a named range here and make it easier so that I can drag that down. So I can just go here and drag it down, right? And these are then my final values. These values in blue. And these are the ones then that I'm going to grab and push back. JunoViewer is going to pick up on these values, so I'm simply referring here to this cell over here, right? And that value you can see in there, and once again I can just copy that down and I've got all of that in there. So if this value, maintenance cost, if it contains a value like something that's not correct, then it is going to pass back error, right? So you can handle that because now you know there is an error in that cell. If you were going to pass this value into your algorithm, whether it's a deterioration model or whatever it is, it will cause big problems, right? So this is a relatively bulletproof process that I've just showed you following this process here. And I recommend that you do that in your ICC templates and your deterioration model pre-checks, and it will save you a lot of headaches down the line. So in this video we focused on numeric data, and we'll make a follow-up video which is similar to this one, focusing on text values. Thanks for watching.